Hello everyone. Today I'll be taking you through an essential component of network communication, the TCP header. This presentation will provide an in-depth look at its structure, its various fields, and how it functions to ensure reliable data transfer. Moving on to the next slide. We'll start with why this is important. Understanding the TCP header is absolutely essential for anyone working in networking. Whether you are troubleshooting network issues, analyzing network traffic, or designing network applications, a solid grasp of the TCP header is crucial. So, what exactly is TCP? TCP stands for Transmission Control Protocol, and it's one of the core protocols of the Internet Protocol suite. Think of the IP suite as a collection of rules that govern communication over the internet, and TCP is a vital part of that. Moving on to the TCP header, I'll provide you an overview of the TCP header. TCP header is a structured format used to manage network communication. It ensures reliable data transmission between devices. The TCP header is where all the control information for a TCP connection is stored. So, it is important to note that the size of the TCP header can vary. It is typically between 20 to 60 bytes long. The variation is due to the options field, which isn't always present. Connection control helps us establish, maintain, and terminate connections. Understanding these fields is crucial for network analysis and troubleshooting. Moving on to the next slide, we have TCP header fields. TCP's main job is to provide reliable, ordered, and error-checked delivery of data. When you send data using TCP, it makes sure that the data arrives at the destination, that it arrives in a correct order, and that any errors during the transmission are detected and corrected. This reliability is why TCP is so widely used in the market. You encounter TCP every day. It's the backbone of web browsing, email, file transfers. So basically, any application where data integrity is paramount, TCP is used. So we have the source port, destination port, sequence number, acknowledgement number, data offset. These fields are the basic structure of the TCP header. Moving on to the next slide, we have detailed explanation of the control flags. Beyond these basic fields, TCP also uses control flags. These are single bit flags that control various aspects of the connection. This SYN flag, or the synchronized flag, is used to initiate a connection. It is the first step in the three-way handshake. The ACK flag, or the acknowledge flag, is set to 1 to acknowledge the receipt of a segment. It's crucial for reliable communication. And finally, the FIN flag, the FIN flag, or the finished flag, is used to gracefully terminate a connection. It signals that the sender has no more data to send. These flags are essential for managing the state and flow of a TCP connection. They dictate how connections are established, maintained, and closed. So these flags control the state and flow of a TCP connection. Now we'll move on to the third slide on how TCP header works in communication. Let's look at how the TCP header works in practice during communication. The most fundamental process is the three-way handshake. This is how a TCP connection is established. First, the sender sends a SYN, or the synchronized packet. Then the receiver responds with a SYN ACK packet, which is a synchronized acknowledgement packet, acknowledging the synchronized and sending its own synchronization request. Finally, the sender sends an acknowledgement packet to acknowledge the synchronized acknowledge. Once the handshake is complete, the connection is established. During data transmission, the sequence and the acknowledgement numbers we discussed earlier are critical. They ensure the data segments are delivered in a correct order and that any lost segments are retransmitted. When it's time to close the connection, TCP uses finished packets or the FIN packets. This is a more complex process than it may seem, as TCP ensures both sides of the communication have finished sending and receiving data before fully closing. Now let's move on to the real world analogy. To help us visualize this, um, let's use a simple analogy: a phone call. Initiating a call is like synchronize, the other person answering is like synchronize acknowledgement. The actual conversation is the data transfer with acknowledgements and responses flowing back and forth. And finally, saying goodbye and hanging up is just like the FIN sequence or the finish sequence. This image we have illustrates that analogy. Just as a phone call has a clear beginning, middle, and an end, so does the TCP connection. This connection oriented nature is the key characteristic of the transmission control protocol, the TCP. Coming on to the summary. In summary, the TCP header plays a crucial role in ensuring a reliable communication over networks as the control center for TCP connections. TCP provides data integrity, error detection, and proper sequencing. Coming on to the last slide, I would like to end the presentation. Thank you for your time. I hope this presentation has given you a clear understanding of the TCP header and its importance. I am happy to answer any questions that you may have. You can drop them in the comment section below. Thanks a lot.